In this experiment, we'll separate a mixture of cyclohexane and toluene using fractional distillation. Set up a fractional distillation apparatus similar to the one described in the lab book. Use a 50 milliliter round bottom flask for the distilling flask and 3 clean 10 milliliter graduated cylinders to collect the fractions. Before assembling, make sure your glass joints are properly greased, otherwise they will freeze. Begin by grabbing a small condenser and secure it with clamps on a ring stand. Make sure the clamps are high enough to allow space for a jack and heating mantle underneath. This will allow for easy removal of the heat source if needed. Attach a distillation head to the condenser and secure it with a clip.
Then attach a thermometer adapter to the top of the head, secure with a clip. Attach a large condenser to the bottom of the distillation head. Clip a vacuum or vent adapter to the end of the condenser. Connect the yellow hoses to the condenser. In hose to the bottom and out hose to the top. And turn on the water. Attach the round bottom flask to the large condenser. Last but not least, raise the jack and turn on the heating mantle.
Measure out approximately 20 milliliters of the cyclohexane toluene mixture in a 25 milliliter graduated cylinder. And transfer to the 50 milliliter round bottom distillation flask. Add a few boiling chips. We'll be using copper as a packing material. Place a 10 milliliter graduated cylinder below the vacuum adapter to receive the first fraction. Obtain a piece of aluminum foil to wrap around your fractionating column.
Once you begin heating, collect fraction 1 until the temperature reaches 81 degrees C. At this point, switch to a second clean 10 milliliter graduated cylinder and collect fraction 2 until the temperature reaches 95 degrees Celsius. Finally, switch to a third clean 10 milliliter graduated cylinder and collect fraction 3 from 95 degrees C until the still pot is almost dry. Record the volumes of each fraction and save some of each fraction in separate labeled vials. Calculate the percent recovery of fraction 1 and fraction 3. We will analyze the samples using a gas chromatograph.